Hey guys, so I just wanted to go over the quiz, the retake of the quiz, because there's a lot of questions on what people missed and how we can go over the answers for that. So I want to give you an opportunity to take a look at our quiz and all the answers. Okay, so our first question was, which of the following has the correct organization of an ecosystem from simplest to most complex? This was straight out of our notes. A species is the most simple. A bunch of the same species together makes up a population, and a bunch of different populations make up a community. So letter B, or the second choice, is your correct choice for that one. I can select it too. Yep, there, and it shows you that that is the correct one. Number 2, according to the graph, the lynx population in the early 1850s was less than 10,000. What is a possible reason for this? Note, the lynx is a medium-sized cat and a hare is related to a rabbit. So hopefully you're thinking about cats, kind of bigger cats would eat rabbits if they're small enough and whatnot, and lynx are predators to rabbits, which is the prey. So this is the predator-prey relationship, and our green is our hare population, and our red is our lynx population. So the lynx population, and this is about 1850 right here, was less than 10,000, but our hare population is huge at that same time. But it had fallen, so it's going to take it a while to recover once there's enough food, which there is now at this point, for the population to increase again. So what you have to put is there was not enough of a prey population to support a larger hare population. There was not enough prey to support a larger predator population of your lynx, okay, in 1850. Number 3, using the data below, what is the average case fatality rate for Uganda during the Ebola outbreak of 2012? So we are looking only at Uganda, and I know a lot of people looked at all of 2012 because that's what we did in our first quiz for some people who had this same data. So looking at just Uganda, you're going to take 4 plus 17, which is going to get you 21, and divide that by 7 plus 24, which is 31, which gets you an average case fatality rate of 67.7. If you had done 57 plus 71 divided by 2, that option is not here, so it forced you to do it that way. Okay. So, number 4, based on the data below, explain a possible explanation for the spike in wildebeest population in June and July of 1989. So, looking in June and July of 1989, we have a huge spike in the wildebeest population. Let's look at our choices. Okay, so the gazelle population, the favored prey, increased, resulting in an increase in the wildebeest population. So, looking at our gazelle population, which is right here, it says it increased. The gazelle population did not increase until after June, which would not account for this. So this can't be true, right? The second option, a reduction in the zebra population, the main predator of the wildebeest, decreased enough to allow, what does the rest of it say? Allow the wildebeest population to grow. So looking at the zebra population, it did decrease, and technically, you could probably make an argument for that, except for the fact that zebra do not eat wildebeest. Zebra are grazers, they eat plants. So looking at the next one, sufficient grass length provided ample food for the wildebeest population to spike. So looking at this, lots and lots of really tall grass. That really, really tall grass right here correlates to the really high population of the zebras, and that means your zebras are eating the grass. And how this actually works in reality is the grass gets super tall, the zebras have to come through and graze it down, and they eat it down to where it's a shorter height that the wildebeest can then eat. The wildebeest, it's too tall for them in April and May, so the zebras have to eat it first, and then the wildebeest can eat it. So that would be the correct answer. And then wildebeest dislike rain and prefer to raise their young during the dry months. That has absolutely nothing to do with anything on this chart, or on any of these charts. So that one can just be tossed out altogether. So that's how you get that one. And I'm presuming at this point, because it is online and I have said that I'm not making it closed book, that people are looking things up. And I know a lot of people are, so I'm glad about that. I know some people have chosen not to, which is fine, or some people weren't aware that they were allowed to for whatever reason. I'm not sure how come they didn't know that, but if you didn't know that, I hope you know it now. Okay, using the data, which explanation below describes the trends seen? So these graphs are very hard to read, and I understand that I got several emails about that. But you don't actually have to read the numbers on it. You just have to look at the trends. So negative numbers are going to mean that it's drier. It's a more severe drought. So looking at these numbers, and the years are represented by color, you can see you needed to find the tallest bars. So the tallest bars were these two here. Even though they're in the negative direction, they are taller than this one here. The tallest bar is 2016. So 2016 was our driest year. Okay? In 2016, we look over here and we see the dead trees by year. There's a lot of dead trees. Not as many as in this one's 2016. There is a lot of dead trees. It's the year with the most dead trees at once, and that would make sense since it's the driest year. There are dead trees in 2015, and there's less in 2017 and 2018 because we're coming out of the drought at this point. And then there's some dead trees accumulated for the 4 years, 2010 through 2014. Okay, so now let's look at our questions and see if we've got, this is our driest year, and this is the number of dead trees. 2010 through 2014 did not have any tree mortality because there is no drought data for that time. Does that look like there are no dead trees in 2010 to 2014? We do have dead trees, so that one cannot be correct. And it says 2016 was the driest year, which accounted for the largest single year increase in tree mortality. So we look at the largest increase and we look at the year 2016. Great, that part's true. Come over here. Is 2016 the driest year? Yeah, it's the driest year pretty much everywhere in the state. It was the driest, except for right here. It was a little wetter or not as dry as, 2018 was drier for these two regions. But the rest of it was either equal to or drier. So that one looks like it's probably true. But let's go ahead and look at 2017 was the driest year, which accounted for the largest cumulative year increase in tree mortality. Well, 2017, this is way less. This is like less than half of the number of dead trees. And 2017 we know was also not the driest year because its bars were not as tall as 2016. And then 2018 was a significantly dry year, which did not affect tree mortality. Well, we know we have dead trees here, so we have an effect on tree mortality. And we also know that 2018 was a really dry year from the data on here. So that cannot be true. So that means 2016 was the driest year, which accounted for the largest single year increase in tree mortality. So that would be the correct one there. Alright, this one is proving to be more challenging than I anticipated it would be. So what is the ultimate source of energy for this food web? Actually, for any food web. If you look at any food web, what is the ultimate source of energy? That would be the sun. Okay, the sun needs to provide the energy to the phytoplankton. The phytoplankton is the largest biomass, but the ultimate source of energy for any food web, for everything on Earth, is the sun. And I believe that was in a special yellow box in our notes. Number 7, consider the food chain of phytoplankton to krill to fish to leopard seal to killer whale about how much of the chemical energy fixed by photosynthesis of the phytoplankton is available for the killer whale if the phytoplankton has 100%. So phytoplankton to krill, and you don't even need to look at the diagram here. Phytoplankton's 100%, krill is then 10%, fish is 1%, leopard seal is 0.01%. I'm sorry, 1%, 0.01%, and then killer whale is 0.01%. So that's that one right there. Okay? So I hope that helps make a little bit more sense to you where the quiz questions came from. Most of it came straight out of your notes. If you were not aware or had not straight out of your notes, but some of it came straight out of your notes. Some of it was being able to put stuff together to get those level 3s. Again, those are higher level questions that are going to be worth 90% of your grade if you can get up to the level 3s. So if you're getting level 3s, you should be getting level 2s, which I understand the sun one was kind of a hard one for kids for some reason. Anyway, if you have questions still, send me an email or check me out during pause, okay? I hope you guys have a great rest of your day.